This is 6.9, lesson 1, and for this lesson we are going to multiply and divide with scientific notation. So we're going to be given multiplication. I have 7.2 times 10 to the third times 1.6 times 10 to the fourth. Since the whole thing is multiplication, we can actually use the commutative property so that we can actually kind of switch up these numbers to where I can actually do 7.2 times 1.6, and then I can have 10 to the third times 10 to the fourth. I can do 7.2 times 1.6, so we'll work that out on the side. 6 times 2 is 12, carry the 1. 7 times 6 plus 1 is 43. We write a 0. We multiply and add. We get 1152, or 12, I'm sorry. 12. No, it should be 1152, I'm sorry. 1152. And then since I have two numbers behind my decimal place, I put my decimal so that I have two numbers behind my decimal place. So far my first two numbers multiplied together give me 11.52 times, when I have two numbers with the same base and we're multiplying, we get to add our exponent. So this is times 10 to the 7th. Now our problem is this is not technically in scientific notation because my first number needs to be in between 1 and 10. So in order for this to be in between 1 and 10, my decimal really needs to be in between my two ones. So I have 1.152 times 10, and when my number gets smaller, my exponent is going to get larger by 1. So this is my final answer. Letter B, we're going to do the same thing. I'm going to multiply my two regular numbers together first. So 2.36 times 1.6. 6 times 6 is 36. Carry our 3. 3 times 6 plus 3. It gives us a 21. We have 12, 14. 0, 6, 3, 2. When we add those up, we get this number. Now we have three numbers after our decimal place this time, so I need 1, 2, 3. So our first number is 3.776 times 10, and we add our exponents. 3 plus 4 is 7. This one is already in scientific notation, so we can leave it alone. So let's take a look at division. With division, we're going to do a similar concept. We're going to divide our two regular numbers. So I'm going to do 9 divided by 4. Well, 4 can go into 9 twice. I subtract. I need to add a decimal and bring down a 0. 4 can go into 10 twice. That gives me 8. Subtract. I have a 2. And 4 can go into 20 perfectly 5 times. So I have 2.25 times. Then when I have this same base and we're dividing, we're going to subtract our exponent. So I need to do 17 minus 4, which is 13. This number is already in scientific notation, so we can leave it alone. Letter D, again we need to divide our regular numbers. So I have 8.37 divided by 2.7. Well, since both these numbers are decimals, in order to divide, we actually move our decimal 1 over for both of these. And then we think, how many times does 27 go into 83? And that is 3 times. We multiply that, we get 81. So I'm left with a 2 and bring down a 7. That goes in perfectly once. So my regular numbers divided is 3.1 times 10. And then we subtract our exponents, top minus bottom. So we have 3 minus 8 is negative 5. This is in scientific notation, so we can leave it as our answer. Letter E, in 2010, the world's population was about 6,860,000,000. The population of the U.S. was about 3 times 10 to the 8th. About how many times larger is the world population than the population of the U.S.? And we're actually going to estimate the population of the world and then write it in scientific notation. So we're going to say the population of the world is about 7 billion. Okay, and in scientific notation, that is going to be 7, because this is where we want our decimal. So 7 times 10 to the 9th power. So to figure out how many times larger the world population is than the US, we actually need to divide. And we're going to do 7 times 10 to the 9th divided by 3 times 10 to the 8th. Just like before, we can divide our regular numbers. We can have 7 divided by 3. 3 goes into 7 twice. We're left with 1. Bring down a 10. Or bring down a 0. 3 goes into 10 3 times. That gives us a 9. With a 1, it's going to continue to happen. So I'm going to have 2.3 repeating times 10, and we subtract our exponents. That's going to give me a 1. So our scientific notation is 2.3 repeating times 10 to the first. Standard form means that I would move my decimal 1 to the right. So it's going to give me 23.3 repeating. Then letter F. A circular swimming pool holds 1.22 times 10 to the 6th cubic inches of water. It is being filled at a rate of 1.5 times 10 to the 3rd cubic inches per minute. How many, we're going to change this to minutes, will it take to fill the swimming pool? So in order to do this, we have to divide again. So we're going to do 1.22 times 10 to the 6th divided by 1.5 times 10 to the 3rd. So just like before, we need to divide our regular numbers. So I have 1.22 divided by 1.5. Since this 1.5 is a decimal, I need to move it 1 to the right to make it a whole number. So we go 15 goes into 12 0 times. 15 goes into 122, I'm sorry, 8 times. And that gives me 120. I subtract, I'm left with 2. Bring down a 0. 15 goes into 20 once. I have a 5, bring down a 0. 15 goes into 53 times. That gives me 45. I have a 5, bring down a 0. I'm going to continue with that 3. So I'm going to get 0.813 repeating as my regular number. And then I subtract my exponent, so that's times 10 to the 3rd. Now this is actually not in scientific notation because this first number is not in between 1 and 10. For this number to be 1 and 10, my decimal really needs to be behind my 8. When this number gets larger, my exponent gets smaller. So this is going to be 8.13 repeating times 10 squared. And in standard form, I would move my decimal 2 to the right. So it's going to give me 813.3 repeating minutes.